today we're going to solve polynomial equations by factoring. So all those factoring techniques that we have just completed going over, we're going to need to use in order to solve and find the x-intercepts for these polynomials. So we have several different types of examples here. What you want to make sure is going on is that the polynomial is equal to 0. If it's not equal to 0, you have to move some things left or right. Find the polynomial, factor the polynomial completely. Set the factors equal to 0 and solve. And some of the things that you may have to do, you will have to do for sure. You will definitely have to use the quadratic formula at some point, and you might have to use the square root property as well. The solutions can always be plugged back into the original equation to see if you got it right. And the number of solutions will be equal to, anybody, the degree. So I'm going to use a different color, the degree. Which at that point could also include double roots or triple roots, and those are roots that show up more than once. So it's possible to have multiple answers of the same number. So let's look at some of the examples. This first example, A, is a greatest common factor only example. What that means is the only way to factor this polynomial is by GCF. And its GCF is x squared. And so you remove the x squared, and you're left with x minus 10. Make sure it stays equal to 0. You're then going to take the factors x squared and x minus 10 and set them equal to 0. X squared equals 0 and x minus 10 equals 0. And you're going to solve them. And so you may need to use the square root property. You may need to use quadratic formula when you get to this step. But when you take the square root of 0, you're going to get 0, but you get 2 of them because the degree of that equation is 2. So you're getting 2 answers from this. So 1, 2. And then the answer to the second part, or the second equation, is 10. And so what we see is that there are 3 solutions because the degree of the problem was 3. So we've got to make sure that everything is included. The next example is a GCF followed by a difference of squares. So the GCF then DOS tells us that this is an example that's got multiple layers of factoring. So this GCF is 3x followed by x squared minus 9, keep it equal to 0. So the factors, 3x and x squared plus 9, or x squared minus 9, excuse me. Okay, so we have 3x and then x plus 3, x minus 3 equals 0. So really, this became 2 parentheses. And then we set the factors equal to 0. 3x equals 0, x plus 3 equals 0, and x minus 3 equals 0. We solve each of those and get x equals 0, x is negative 3, and x is positive 3. Showing that we have 3 answers that match our degree of 3. Example C brings us to sum and difference of cubes. So the sum and difference of cubes, this is going to be a little bit more difficult. We have a binomial trinomial, so we have x plus 2, x squared minus 2x plus 4. And the first answer right here is going to be x equals negative 2. That's the simple one. X equals negative 2. And that's one of our three answers. But here, on the next part, the trinomial, we actually are going to have to use the quadratic formula. This won't factor, and since we have to solve it, we got to figure out a way to do it. So, we use the quadratic formula, which is going to be 2 plus minus b squared, which is negative 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 4, all divided by 2 times a, which is 2. Now all we have to do is simplify this, okay? So inside the parentheses, right here, this is 4 minus 16. So 2 plus minus the square root of negative 12. That's negative 12. 4 minus 16. All divided by 2. Okay, so now this has to be simplified, which will be 2 plus minus. This is going to be, this is 4 times 3. So 2i square root of 3, all divisible by 2. And then the 2's will divide each other out, giving us the final version, 1 plus minus I square root of 3. That represents two answers. You have one answer here from the original, which matches our degree of 3. Moving on to page 6, and example D, we have a greatest common factor followed by an easy trinomial. So this should be a lot simpler than example C, which has a quadratic formula. So our GCF in this problem is just going to be an x, followed by an easy trinomial, x squared plus 5x minus 24, keep it equal to 0. We'll continue to factor the trinomial, x, 8 times 3 will be 24. It has a difference of 5. The larger number carries a sign. So we have three distinct factors that will match our degree. X equals 0, x plus 8 equals 0, x minus 3 equals 0. To give us the three answers, x equals 0, x equals negative 8, and x equals positive 3. Again, three answers because our degree is 3. Very similar to that, except now we get into a harder trinomial. We have a GCF again, which is x, followed by a harder trinomial, 3x squared, plus 14x minus 5 equals 0. The harder trinomial factors into 3x, x, 5, 1. 3 times 5 has to be positive. We have our three factors, x equals 0, 3x minus 1 equals 0, and x plus 5 equals 0, which give us our three answers, x equals 0, x equals 1/3, and x equals negative 5, which once again matches the degree of our problem. Example F brings us an easy higher degree trinomial. So it's higher degree because it has an exponent of 4. So we're going to have 4 answers for this problem. It's an easy trinomial because it has a leading coefficient of 1. So we can start to break down or factor this polynomial by just saying that it has x squared and x squared. We multiply to get 5. We have a positive 5 and a negative 1. Now, a deeper look into this problem shows us that we have difference of squares. So we can continue to factor this. X squared plus 5, x plus 1, x minus 1 equal to 0. These three factors now need to be solved. X squared plus 5 equals 0. X plus 1 equals 0. And x minus 1 equals 0. The first factor is not so easy to solve because you're going to have to take the square root. So we need to subtract 5 from both sides. X squared equals negative 5. We'll take a square root. Remember that square root gives you two answers. So we'll have x equals plus minus, that's two answers. I, because of the negative, square root of 5. The second and third factors are much quicker. X equals negative 1 and x equals positive 1 for a grand total of 4 answers that matches our degree of 4. Final example is going to be a factor by grouping. So we take parentheses, we put them around our first and second sets of numbers. We pull out a greatest common factor, 4x squared. That leaves me with x plus 3. The second GCF is negative 3, followed by x plus 3. My two parentheses are the same, so I can bring these two down to 4x squared minus 3 as the two GCFs, and then the same, which is x plus 3. Keep that equal to 0. We now separate the factors. 4x squared minus 3, keep it equal to 0. X plus 3 equal to 0. And we need to solve each of them however we can. So basically we're going to use SADMET to solve both of these. So 4x squared equals 3. We're going to divide by 4. X squared equals 3 over 4. No need to turn that into a decimal. Take the square root of both sides. X equals plus and minus, two answers. Square root of 3 does not simplify. The square root of 4 is 2. So that's 2 of our 4 answers. Sorry, 2 of our 3 answers. And our last answer is just going to be x equals negative 3, which gives us our total of 3 answers to match this degree.